What if the most dangerous storm on the planet right now isn't even being talked about on the news you watch every day? What if it's already tearing through communities that are still picking up the pieces from the last one, and most people outside that region have no idea it's happening? Before we go any further, hit that like button right now. It costs you nothing, but it tells me you want more of this. Subscribe if you're new here, turn on notifications, and let's get into one of the wildest and most important weather stories of the year. Somewhere out in the western Pacific Ocean, far from the headlines most people scroll past every morning, a storm grew from almost nothing into a monster in less than 3 days. Scientists have a name for this kind of growth. They call it rapid intensification. And when it happens, it changes everything about how much warning time people get before disaster arrives at their door. This is the story of that storm, where it came from, how fast it grew, what it did to the islands in its path, why the people living there were already exhausted and terrified before it even arrived, and why scientists are saying this isn't just one unusual storm, it's part of a pattern that is quietly becoming the new normal for our oceans. Let's start at the beginning, because the beginning tells you everything about how deceptive these storms can be, and how easy it is to underestimate them until it's almost too late. In the last days of June, meteorologists noticed a small cluster of clouds and thunderstorms drifting over warm ocean water east of the Philippines. At that stage, it looked like nothing special. Weather agencies barely gave it a name. It was just one of dozens of little disturbances that pop up in the tropics every single month, and most of them fade away without ever becoming a real threat to anyone. But this one didn't fade. Within days, it organized into a proper tropical storm with a defined center of circulation. Forecasters started watching it more closely because the ocean beneath it was unusually warm, warmer than average for that time of year, and the atmosphere around it was calm in exactly the way that lets a storm grow without anything holding it back. There was nothing tearing at its structure. There was nothing cutting off its fuel. Every single condition that meteorologists dread seeing line up together was lining up together. Then it exploded. In under 72 hours, this storm went from a loose, disorganized system that barely had a defined center to a full-blown Category 5 super typhoon with winds strong enough to flatten buildings and strip trees bare. That kind of jump from weak tropical storm to Category 5 in that short a window is rare even by the standards of the world's most active storm basin. It's the kind of transformation that keeps hurricane scientists up at night because it means the difference between having a full week to prepare and having barely 48 hours to get people out of harm's way. At its peak, this storm carried sustained winds over 175 miles per hour. To understand how extreme that number really is, think about it this way. A storm officially becomes a hurricane or typhoon once its winds reach 74 miles per hour. That's already strong enough to snap power lines and rip roofs off older homes. A Category 5, the highest and most dangerous category that exists on the entire scale, starts at 157 miles per hour. This storm didn't just barely cross into Category 5 territory. It blew past that line and kept climbing, settling in near the top of what the scale can even measure. Its central pressure, which is basically a way of measuring how intense and tightly wound a storm's core is, dropped to levels that put it in the same range as some of the strongest tropical cyclones ever recorded on Earth. The lower the pressure at a storm's center, the more violent and powerful that storm is. And this one was sitting near the extreme end of what our atmosphere is even capable of producing. In the same tier, scientists reserve for the handful of legendary storms that get studied for decades afterward. The eye of the storm, the eerily calm circular center that sits in the middle of all that violence, stretched about 21 miles wide. Satellites showed it as a nearly perfect symmetrical circle, which is exactly the kind of structure meteorologists associate with the most dangerous, most organized storms out there. It wasn't messy. It wasn't falling apart at the edges. It was locked in, tightly wound, and it was aimed directly at a cluster of small islands sitting in the middle of the open ocean with nowhere to hide. And here's where the story turns from a weather event into something much heavier, much more human. Because those islands had already been through hell just months earlier, and they hadn't even finished burying the damage from the first disaster. Roughly 3 months before this new storm formed, a previous super typhoon had already torn through the exact same region. That earlier storm was one of the strongest ever recorded in that part of the world, with winds close to 185 miles per hour at its peak. It made a direct hit, moving slowly across the islands, which meant it didn't just pass through and leave in a matter of hours. It sat there, battering everything for an extended stretch of time, dumping over 20 inches of rain, ripping through the power grid from one end of the islands to the other, and causing well over $1 billion in damage. Lives were lost, homes were destroyed down to their foundations. And 2.5 months later, when this new storm was already forming out in the ocean, many of those same communities still didn't have their electricity back on. Picture that. For a second, families still living under blue tarps instead of solid roofs. Emergency shelters still occupied because homes weren't safe enough to return to. Power lines still down across entire neighborhoods. Water systems still running on backup generators. And now, a second monster storm, potentially even stronger than the first one, tracking straight toward them again, as if the ocean simply wasn't finished with them yet. This is the part of the story that turns a weather report into something deeply human, something that sticks with you long after the numbers fade. Because for the people on those islands, this wasn't an abstract figure on a satellite image or a line on a forecaster's map. This was their second nightmare in the same calendar year. They hadn't even finished recovering from the first one. Imagine trying to explain to your children that the storm that destroyed their school might be followed by an even bigger one before the first one has even been repaired. As the storm turned closer, forecasters faced a genuine high-stakes problem: the major weather. Models didn't agree on exactly where it would make its closest approach. One major American forecasting model showed the eye passing directly over two of the larger, more populated islands in the chain. Another respected European model shifted the track further south, putting the worst of the eye wall over a different set of islands instead. That kind of disagreement between models, just days before landfall, meant that entire communities didn't know for certain which direction to brace for the strongest impact. Emergency managers had to prepare every single island as if it might take the direct hit, because nobody could say with confidence which one actually would. That uncertainty alone is exhausting for people who are already running on empty from the last disaster. Local officials didn't downplay any of it, and to their credit, they never tried to soften the language just to keep people calm. Public warnings used blunt, serious wording. Phrases like extremely dangerous and life-threatening situation were used without hesitation, repeated across broadcasts and emergency alerts. One official said publicly that they were aiming for 0 fatalities and admitted, almost with a kind of raw honesty you don't often hear from officials, that they genuinely hoped that's how it would turn out. Ports suspended all operations completely. Schools shut their doors well in advance. Even major military installations in the region told non-essential personnel to stay away from their bases entirely. When a facility built to withstand serious threats takes a storm that seriously, you know the danger is not being exaggerated. If you're finding this story as wild as I am, make sure you're subscribed. Because we're just getting to the part where scientists start explaining why this kind of storm is becoming more common, not less, and what that means for the future. When the storm finally made its move, the center passed directly over a small island home to about 2,000 people. Winds there exceeded 150 miles per hour as the eye rolled directly overhead, an experience survivors would later describe as sounding like the world itself was being torn apart outside their walls. Communication with that island was knocked out almost immediately, which made it incredibly difficult for outside authorities to even know how bad the damage was in the first few critical hours. Nobody outside could reach anybody inside. For a period of time, that island simply went silent to the rest of the world. A nearby, more populated island took a slightly less direct hit, but still recorded wind gusts over 110 miles per hour and broke a daily rainfall record with more than 12 inches of rain falling in a single day, an amount that would overwhelm drainage systems even in cities built for heavy weather. Now here is the part of this story that genuinely surprised even the experts who study these storms for a living, the part that turns this from a tragedy into something almost unbelievable. Despite winds over 150 miles per hour tearing directly across a small, vulnerable island, despite record-breaking rainfall, despite widespread damage to buildings and infrastructure that was already weakened by the previous storm just months earlier, there were no confirmed deaths. Not one. Let that sink in for a moment, because it matters more than almost anything else in this entire story. A storm capable of producing catastrophic, historic destruction moved directly over a populated island, and the community came through it without losing a single life that we know of. That outcome wasn't luck, it was preparation, executed with discipline under enormous pressure. In the days before the storm arrived, warnings went out repeatedly and clearly, over and over, until the message became impossible to ignore. Evacuation orders were issued early, well before conditions turned dangerous. Emergency shelters opened across the islands and filled up so fast that some had to start turning people away, which sounds like a failure, but is actually proof that people were listening. Ports shut down before the worst weather even arrived. People were told, in plain, direct language, to be somewhere safe before the storm hit, not to wait until conditions got bad, but to move before that point ever came at all. That message, delivered early and taken seriously by people who had already lived through one devastating storm that same year, is very likely the single biggest reason the death toll stayed at 0. There's a lesson buried in that outcome, and it applies far beyond this one storm, far beyond this one region. The intensity of a storm is decided by nature, by the physics of warm ocean water and swirling wind. But how Many people survive it is decided by human choices made in advance, sometimes days before the sky even starts to darken. Early warnings only save lives if people act on them before it's too late to move, and this time enough people did. After passing over the islands, the storm didn't just fade away into the ocean and disappear. It kept moving west, still carrying sustained winds over 150 miles per hour, as it crossed into open water, heading toward Taiwan and eventually the coast of mainland China. Forecasters expected it to gradually weaken as it moved over slightly cooler water and ran into more wind resistance higher in the atmosphere. But they were clear and public that it would likely still be a powerful storm capable of serious flooding and wind damage when it reached land again. Taiwan's mountainous terrain adds its own layer of danger here, because when a tropical system runs into mountains, the rain gets squeezed out even harder as air is forced upward, dramatically increasing the risk of flash floods and deadly landslides, even after the wind speeds themselves have already started to drop. So now let's talk about the question everyone eventually asks. When a storm like this makes headlines around the world, is this normal, or is something bigger, something more permanent, going on beneath the surface? Scientists who study tropical cyclones are careful here, and it's worth being just as careful ourselves, rather than jumping to easy conclusions. The total number of tropical storms and typhoons forming around the world each year hasn't dramatically increased compared to historical records stretching back decades. That part genuinely hasn't changed much. What has changed, and what the data consistently shows across multiple independent studies, is that a larger share of the storms that do form are reaching the most extreme categories available. Category 4 and Category 5 storms are making up a bigger slice of the total number of storms than they used to a few decades ago. And on top of that, storms are reaching those extreme intensities faster than they used to, sometimes uncomfortably close to populated land, leaving less and less time to prepare with each passing decade. That's a full third of this section, and we've still got a lot of ground to cover, so let's keep moving, because the science behind why this is happening is genuinely fascinating once you break it down piece by piece. The reason comes down to basic physics, and it's not complicated once you strip away the jargon. A tropical storm is essentially a giant heat engine floating on the surface of the ocean. It pulls warm, moist air up from the ocean's surface, and as that air rises and cools at higher altitudes, it releases energy, which is exactly what powers the storm's spinning winds. Warmer ocean water means more available energy sitting right there, ready to be consumed. More. Available energy means storms can grow faster and reach higher peak intensities than they otherwise would. Ocean temperatures in the western Pacific, which is the most active typhoon basin on the entire planet by a wide margin, have been running above historical averages in recent years. The very month this storm formed was recorded as one of the warmest versions of that month ever measured globally, with average surface temperatures well above levels recorded before large-scale industrialization changed the planet's climate. Warmer oceans don't guarantee that any single storm will explode into a monster overnight, but they do load the dice in favor of it happening. They create more opportunities for rapid intensification to occur, and they raise the ceiling on how strong a storm can ultimately become once it starts feeding. Rapid intensification itself has a specific scientific definition that meteorologists use to track it precisely. It's when a storm's maximum sustained winds increase by at least 35 miles per hour within a single 24-hour period. The storm blew past that threshold by a wide margin, going from a barely organized system to a full Category 5 in roughly 48 hours total. For that kind of explosive growth to happen, scientists say 3 conditions basically need to line up at the exact same time, almost like pieces of a puzzle clicking into place. First, the ocean needs to be warm and not just at the surface, where the sun heats it directly. It needs to be warmed down through the deeper layers of water, too. That's because a powerful storm churns up water from below as it spins and moves, and if that deeper water is cold, it cools the surface underneath the storm and effectively cuts off its own fuel supply from beneath. In this case, the warm water extended well beneath the surface, for a considerable depth, giving the storm what was essentially an unlimited energy source to draw from as it moved. Second, wind shear needs to be low. Wind shear is the change in wind speed and direction at different altitudes above the storm, and high shear can literally tear a developing storm apart before it ever has a chance to organize properly. In this storm's early development phase, the surrounding atmosphere had very little shear acting on it, which let it build its internal structure without any real interference from the atmosphere above. Third, the storm needs an efficient outflow channel high up in the atmosphere, essentially an exit route for all the warm, moist air that rises up through the storm's towering thunderstorm clusters. When that outflow is clean and unobstructed, the storm's internal engine can spin faster and more efficiently, almost like a chimney, drawing smoke upward without any blockage. In this case, conditions to the north actually helped enhance that outflow even further, giving the storm an extra push right at the moment it was intensifying the fastest. All three of these ingredients lined up at the same time over the same patch of ocean, and the result was one of the fastest intensification events seen in that entire region in recent memory, a case study that meteorologists will likely be referencing for years to come. Here's why this matters far. Beyond the science itself, beyond the textbooks and the satellite data, a storm that builds gradually over a full week gives coastal communities a progressively escalating warning. People see it coming for days on end, and they have time to adjust their plans as the forecast becomes clearer and more certain with each passing day. But a storm that jumps from a weak tropical system to a Category 5 monster in just 48 hours delivers a much more sudden, jarring escalation in threat level. Forecasters in this case caught the intensification early enough that the islands in its path still had several days of genuine lead time, and that lead time is very likely a huge part of why the death toll stayed at 0. But not every region and not every community around the world has forecasting infrastructure and public trust built up strongly enough to react as effectively when a forecast changes that dramatically, that quickly. If this is opening your eyes to how these storms actually work behind the scenes, share this video with someone who lives somewhere that gets hit by hurricanes or typhoons. It might genuinely help them understand a warning the next time one shows up on their phone. Now, let's talk about why these specific islands are so vulnerable in the first place, because their geography plays an absolutely massive role in this entire story, arguably as big a role as the storm itself. These are small island communities, some with populations only in the low thousands, spread across a chain that covers a relatively tiny total land area sitting in the middle of a massive ocean. Nearby, a separate island territory has a population in the range of 150 to 160,000 people, still small by most standards but large compared to its neighbors. These communities are separated from major supply chains and reconstruction resources by thousands of miles of open ocean in every direction. When a major storm damages roads, ports, power plants, water treatment systems, hospitals, and communication towers, the timeline to rebuild isn't measured in weeks like it might be on a mainland. It's measured in months, sometimes far longer, because every generator, every piece of replacement equipment, every construction crew has to be shipped or flown in across enormous distances, often waiting in a queue behind other disaster zones needing the same resources. When the earlier storm hit these islands months before, it damaged that infrastructure severely, tearing through systems that had taken years to build. Recovery was still incomplete when the second storm arrived on the horizon. That means the second storm wasn't simply adding damage on top of infrastructure that was fully intact. It was adding damage on top of infrastructure that was already weakened, already stretched thin, already running on backup systems in some places, and improvised fixes in others. The compounding effect isn't simply double the destruction you'd expect from two separate storms. It's something worse than that, because recovery resources, funding, and outside attention all have to be split and stretched across two disasters in the same year instead of one, diluting everything that would normally go toward full recovery. This raises a bigger question that goes far beyond just the weather itself. How do small, remote island communities build genuine long-term resilience against a pattern of increasingly intense storms hitting the same limited geography again and again within the same year? That's not just a weather question anymore, and it never really was. It's a policy question. It's an infrastructure investment question. And for many of these communities, it's ultimately a question about whether the support they need to truly recover ever fully arrives before the next storm inevitably forms out at sea. While all of this was happening, meteorologists were also quietly watching other systems developing elsewhere across the region, because the atmosphere rarely produces just one threat at a time. A separate, less intense tropical system was tracking toward the coast of China around the same period, expected to bring heavy rainfall to coastal areas without ever reaching anywhere near the same intensity as the main storm we've been following. Parts of southern Japan were expecting elevated rainfall totals from moisture connected to the same broader weather pattern sweeping across the region. And across South Asia, monsoon rains were already hitting several countries at the same time, part of a broader, extremely active stretch of tropical weather across the entire continent during that same period. Even the Bay of Bengal, on the completely opposite side of Asia, was being watched closely for potential new tropical development in the days that followed the main storm's landfall. It's a striking reminder that these storms rarely happen in total isolation from one another. The atmosphere works as one connected, interlinked system, and an unusually active pattern in one ocean basin often lines up with unusually active patterns elsewhere at exactly the same time. Almost like the whole planet's weather machinery shifts into a higher gear together. So what do you actually take away from all of this, beyond the wild numbers and the almost unbelievable survival story we just walked through together? A few things stand out clearly, and they're genuinely worth remembering the next time a storm warning shows up in your own area, no matter where in the world you happen to live. Early warnings exist for a reason, and they're issued days in advance specifically, so people have enough time to act before conditions turn dangerous. Waiting until a storm is only a few hours away to start preparing is often far too late, especially with storms capable of intensifying as fast as this one did. When forecasters start using serious, urgent language while a storm is still days out, that's the moment to take action, not the moment the wind actually starts picking up outside your own window. Evacuation shelters save lives, full stop, no exceptions. The fact that shelters on these islands filled up past capacity before the storm even arrived is very likely the single biggest reason nobody died in this entire event. People living in older buildings, homes with roofs still damaged from the earlier storm, or low-lying coastal properties, need to move to safer ground before conditions get dangerous, not after the winds have already started howling. Storm surge deserves just as much respect as wind speed, arguably even more respect than it usually gets. A lot of attention naturally goes toward wind numbers because they're dramatic, easy to repeat, and easy to picture in your head. But storm surge, the wall of ocean water pushed inland by a storm's powerful winds, is historically responsible for the majority of tropical cyclone deaths worldwide, far more than wind alone. A powerful storm hitting a low-lying coastal area can produce surge of 20 feet or more, and in the most extreme cases, that amount of water simply isn't survivable inside a typical structure caught directly in its path. And finally, having a communication plan with the people you care about matters more than most people ever stop to think about, until it's suddenly too late to arrange one. When communication was cut off on that small island right after the eye passed over, it created real agonizing uncertainty and made damage assessment far harder in those first critical hours after landfall. Knowing in advance where family members will shelter and having an agreed way to check in once conditions finally allow it reduces panic enormously and helps emergency responders understand exactly where help is needed most urgently, instead of guessing blindly. Here's the bigger picture that scientists keep returning to again and again in study after study. The total number of storms forming each year hasn't necessarily exploded overnight, but the storms that do form are increasingly capable of reaching extreme intensity, and they're doing it faster than they used to just a generation ago. That combination, rising ocean heat paired with faster intensification, is exactly why meteorologists are watching this typhoon season and every typhoon season going forward from here with a level of seriousness that goes far beyond just tracking wind speeds on a colorful map. This particular storm crossed from a barely noticeable disturbance drifting over the ocean to one of the most powerful storms on the entire planet in under 3 days. It slammed directly into communities that hadn't even finished recovering from the last disaster that struck them. It produced winds over 175 miles per hour, a pressure reading that ranks among the most extreme ever recorded anywhere on Earth, and rainfall that broke local records that had stood for years. And somehow, through early warnings, filled shelters, and communities that had already learned hard, painful lessons the first time around, it resulted in 0 confirmed deaths on the islands it hit the hardest. That is not the story of nature being gentle. Nature was not gentle here at all, not for one single moment. That is the story of preparation working exactly the way it's supposed to, even when the storm itself absolutely refused to cooperate or hold back. The Western Pacific typhoon season isn't anywhere close to finished when a storm like this passes through. More systems will form in the weeks and months ahead. Some of them will intensify quickly, the same explosive way this one did, catching people off guard all over again. And the communities in that part of the world, already stretched thin from back-to-back disasters within the same year, will have to face that possibility yet again, knowing that the next storm could just as easily be the one that finally overwhelms what little recovery time they've managed to claw back. If there's one thing worth carrying away from this whole story, one single idea to hold on to after everything we've covered, it's this. The strength of a storm is written by the ocean and the atmosphere, forces far beyond any human being's control. But how many people walk away from it alive is written by something else entirely, by warnings issued early enough to matter, by people who choose to actually listen instead of waiting it out, and by communities who move to safety before the sky gives them no other choice left at all. That's the real story hiding behind the world's most powerful storms. Not just how strong they manage to get, but how prepared the people standing in their path manage to be when it finally arrives. If this video taught you something new about how these storms actually form and why they're getting more dangerous with each passing year, don't just scroll past it and forget about it tomorrow. Hit, like, drop. A comment telling me what surprised you the most, and subscribe so you don't miss the next breakdown the moment the next major storm starts making headlines. Stay safe out there, wherever you're watching this from, and I'll see you in the next one.